Hi, so in the session of IoT, today we'll study about cellular IoT. Also referred as this. So we can say that we will study here that how the cellular technologies will enable your Internet of Things here. So Internet of Things as is the connection of anything, anywhere, any place. That means any smart device is connected here to the internet fashion manner, and then this particular device here will be communicating with the another application lying on some another cloud platform here. So that means the connection mode here, that means the various enabling technologies here are the key drivers for your internet of things here. So we have been discussing that the various technologies that means if you want to connect here to the local gateway, your personal area network techniques are used. But some devices are here connected to your wide area networks also. So now we're talking here about your cellular IoT. So that means the cellular technologies have founded a very strong ground, and we can say that a huge potential here for acting as a radio access for your IoT. That means these here wants to act as the radio access for IoT. That means these cellular technologies here are going to be key drivers here for the connectivity of your IoT, because the coverage here of this cellular infrastructure is very huge. So that means they can support here the number of devices here. So many standardizations here are going for your cellular IoT. So we can say that cellular IoT, your cellular IoT standardization effort work is being here carried by the 3GPP project here. That means what they want to do is here want to use the existing cellular infrastructure for your IoT access. That means they wants to reduce or to avoid the maintenance and operation of a parallel network, because we will be using here the cellular techniques like your GSM, your LT, and the upcoming fifth generation of technology. So we don't want to uh, increase here the burden of maintenance and operation of a parallel network. So that means we have to use the existing cellular infrastructure here for enabling the IoT. So this complete infrastructure, which is using your cellular technologies here as a connectivity platform for your IoT, that is referred as your cellular Internet of Things here. Now, when you will be using the cellular technologies here for Internet of Things, so there will be certain challenges here for the cellular operator here, because they have to operate here for your low bandwidth, low power, and simultaneously they have to provide here the security and privacy here, because we know that a billion of devices there that will be connected to your cellular infrastructure. So the solution here for this problem, that means to overcome these requirements, has come over here from the existing structures. That means from the existing like GSM and your LT systems here. So under these projects, they just want to have, or the cellular IoT here will be providing a new radio access technology, but it will be harnessing here the existing cellular infrastructures. Now, there are basically two groups working here for this project. Now, first of all, we have here, we're saying that the GSM and LT here is mostly used for enabling the cellular IoT. So, GRAN group here is working only on the GSM evolution here for your IoT, because this infrastructure is a long-lasting infrastructure here. Above that, we have a RAN group which is focused on for the LTE evolution for your machine type communication, your machine to machine communication, which has now evolved to your Internet of Things here. So the main standard here for your cellular IoT are EC. These are the different 3GPP releases. So various network vendors here are working for the evolution of IoT. That means the cellular technology enabling your IoT. ECGSM, which is your extended coverage for GSM. So this project here has been started by Ericsson. Then we have here narrow band NB cellular IoT. So this is basically a collaboration of Huawei and Qualcomm. Then we have NB IoT, which is separate work done here by Ericsson. So other network vendors like your NSN, Alcatel-Lucent, all these here are working towards the enabling their cellular infrastructure for your Internet of Things here. So now we will have a look on the architecture layout of your cellular IoT here. So we have the architecture here for the cellular IoT. So we here basically start from your devices and gateways. So a large number of devices here. So this is your wireless, you can say that local or personal area network here. So like this, it will be communicating here with your access and aggregation. Now, if I have here DSLM, or I can have here like E node B or node B 3G RNC. These, after you access an aggregation, you have the mobile core network. Like it will have. Now here I have this mobile core network here. So these are the various. So this is basically your LTE core network, which is acting here as a mobile core network for your cellular IoT. After that, you have here the IoT platform. From your access and aggregation towards your core network, mobile core network, the next you have is the IoT platform here. So IoT platform basically first comprises of your connectivity platform here, and then the application platform here. So like this here, connectivity platform here, managed management of devices and services, and then connected devices platform here. After the this application platform is basically towards the end user, that is, it has M to M communication and M to M analysis. So this basically has here the user end. So this is here the architecture layout for your cellular IoT. So now, first of all, we have here your devices and gateways. That means the devices here will be comprising of your the various smart devices, which are your sensor embedded, which will be collecting the information here, and then with the help of the local gateways, transferring this information to your core network here. So for devices and gateways, for example, if we take your example for your IoT device, so it could be your simple washing machine, which is your uh, a communication enabled device that is providing the connectivity with the help of these gateways. That means it is able here to send the information to some another application in another cloud platform. That means another smart device, which is your smartphone. It could be your tablet. So that's how connectivity is between two different smart devices with the help of these local gateways. So local gateways, either I'm using here a personal area networks, or directly we can connect to a wide areas network, that is to my with the help of your cellular technologies here. So you have devices, you have gateways, you have the wide area network. So it just depends that the application of this access technology depends upon in what kind of scenario you are using this IoT here. If it is wide area network, then the cellular access technologies are best for your Internet of Things here. So this is your access and gateway part. And after that, you have the access and aggregation, which is basically referred as your access network here. So as we can say that if simply you are having here the E node B, which is for your LT system, or either you utilizing the node B, the 3G RNC. So this is your access and aggregation parts from which you are accessing the radio access. Now this radio here is shared between the customer and the IoT traffic here. So this here also depends upon the application here. So different, we can say that this cellular technology here is enabling a wide area of IoT. That means the connectivity level will enhance with the help of this access and aggregation, so that the applications of your Internet of Things will increase here. So it just includes the platform here as your cellular technology enabled. Like your for LT system, we have the evolved node B here. So this is the aggregation part for your information from your devices and gateways. Now moving further, we have the third entity here, which is your mobile core network. This access network is here connected to your mobile core network. Now this is the core network here for your LT system, because in present day the LT MTC evolution is going moreover to support mobile machine to machine communication. So we can say that for the IoT here. So basically, if you talk here about this access, so the guard bands or the blank carriers here are utilized. That's why we are talking here about the narrowband IoT or the narrowband LT for your Internet of Things here. Now I have the various devices here, the various ND units like my mobility management entity. So this part here comes into play because it here depends upon the application, whether it is mobile, whether it's stationary, whether it is a wide area network. So this is your mobility management, your serving gateway, your packet data network, your subscription profile policy, and charging profile here. So all this is here is contained in your mobile core network. So this is your cellular network here supporting the IoT. So for your access, we're using here the low bandwidth because that is a requirement here for IoT that we have to use the low bandwidth and low power, and we require the low throughput also. So for access, we are basically utilizing here the guard bands or the blank carriers. So mainly for your narrow band Internet of Things, we're just using the 2 kilohertz of bandwidth. So we will be studying about this narrowband IoT and LTE in our next sessions. Now, from a core network, we have then the IoT platform because the application here will be delivered on the IoT scenario. So we have the IoT platform, which basically consists of two parts: your connectivity platform and your application platform here. So this connectivity platform basically uh, consists of a communication server also because it is connecting this mobile core network to your IoT application platform here. So this connectivity platform basically includes rating systems, or we can say that it connects us to the charging system of the operators. Further that it also contains the management of the various number of devices, the services. That means it here includes storage, forwarding, and most importantly the protocol translation. Protocol translation here because different types of protocols will be used here, but they are mostly supporting here your IoT platform like your MQTT, your COP, or XML, etc. Now, after a connectivity platform, we have the application platform. So this application platform is also referred as AEP, which is an application enabled platform. So it basically platform provides it how to build the application and how to run that application. So that means it is here doing the mobile to mobile communication. That means it is here finally allowing the information to be transferred from one smart device to another smart device and including that machine to machine analysis here. So it is here the storing of the data, forwarding of the data, and more importantly, that useful content of the information or the application here has to be provided to the user here. So this application platform also consists here some rule engines and communication servers which enables to deliver the application to the particular user over there. Now, we know that the implementation of certain technology here comes with a certain number of challenges. That means the work here mostly is to be done regarding your mobile core network. That means the standardization for your mobile core network. So basically, two forces are here for this mobile core network standardization. That means efforts are here for the standardization of this 3GPP core network here. So this standardization is required because these core network operators here are connected to the IoT platforms. Two forces here are working here. The one is basically working for machine type communication, and another here, the force which is working, that is suggesting or allowing the use of certain application and technologies, which includes your software defined networking and network functions virtualization. So with the help of these technologies, Geo Forge's LT or your upcoming fifth generation of system is supposed to act as a key driver for your IoT. So these technologies with SDN and unit network function virtualization here. So these technologies are here supposed to allow the software-based core network architecture. That means with the help of the virtualization of various elements and in SDN techniques, the separation of a control and data plane, what they want to have is that the core network here can be sliced and scaled according to the application. So that means the mobile networks can virtualize the certain instances of your core network depending upon the IoT use case. So that also reduces here a large number of uh, hardware here, because with the help of our function virtualizations we can create certain instances of a particular network here. So other network considerations related to your IoT, cellular IoT platforms basically includes like the virtualization of your radio access network. So that is basically use virtualized radio access network or your virtualized OSS or your BSS here. So these technologies, if enabled here with the cellular technologies, that means your SDN and NFV. So your fifth generation of system is here a key driver for your Internet of Things here. Now, after that, the use case of the cellular IoT has a very diverse range here also, because it here extends from, or we can say that it starts from your wearable devices, then these are basically your cellular IoT use cases. So your wearables, your smart homes, your smart cities, telematics, health monitoring. So the cellular IoT, we can say that these cellular access technologies are supposed to act as a backbone for your Internet of Things. Now these are the various devices. I'm just mentioning here some of the use cases. Now each of these will require different data rate, yet a low data rate. And you will have parameters here like the data rate, the battery, speed, that's your mobility. It will like vary here from your wearable devices. Now these here are supposed to be mostly fixed. Then your telematics, your health monitoring, and your transportation. So each of these will have these various parameters here, different data rate requirements. So basically that here can be supported by your cellular infrastructure. So in this session of your cellular IoT, we just studied about an infrastructure of your cellular system, how it will support your Internet of Things here. So in our next sessions here, we will be studying about the various technologies which has here evolved to act as an technology enabler for your IoT. So this is all here for today's session. Thank you.